There is a region beyond most of the planets in the solar system called the Kuiper belt. The first object discovered in this area was Pluto. This discovery, however, was just the beginning of uncovering the vast array of objects within the Kuiper belt. It took many years for astronomers to realize the full extent of what lay beyond Pluto. For a long time, Pluto was considered a unique anomaly in the solar system. Only in the early 1990s did scientists begin to uncover more objects in this distant region, marking the start of a deeper exploration and understanding of the Kuiper belt. The first time images of the Kuiper belt were captured was on November 2, 2015. These initial images provided astronomers with a fascinating glimpse into this remote part of our solar system. They were some of the most interesting ever taken from space, revealing the complexity and diversity of objects in the Kuiper belt. These images, however, have recently been surpassed by the even sharper images obtained by the James Webb Space Telescope. The advanced technology of this telescope has allowed scientists to study the Kuiper belt in unprecedented detail, offering new insights into its composition and structure. The Kuiper belt, a cool donut-shaped region, lies in the outer solar system beyond Neptune, the eighth planet from the Sun. This region is of particular interest to astronomers because it is unlike any other part of the solar system. Initially, the Kuiper belt was thought to be intriguing because of its unique shape. However, it soon became clear that this belt would be one of the most fascinating areas of the solar system, holding many secrets about the formation and evolution of our planetary neighborhood. The belt is named after scientist Gerard Kuiper, whose work in the mid-20th century helped to understand the area beyond Pluto. In 1951, Kuiper wrote a scientific paper speculating on the possibility of objects beyond Pluto. His forward-thinking ideas laid the groundwork for future discoveries. Pluto was initially thought to be a main feature of the Kuiper belt, however, it is now known that Neptune's orbit, not Pluto's, defines the inner edge of the belt. Neptune's gravitational pull has been crucial to this region, shaping the orbits of many objects within the Kuiper belt. Astronomers appreciated Kuiper's innovative ideas, although his predictions did not exactly match what was later observed in the belt. Despite this, his work was instrumental in advancing our understanding of the outer solar system. Scientist Clyde Tombaugh discovered Pluto in 1930 in what we now call the Kuiper belt. At the time, astronomers did not know much about the outer solar system and did not expect to find so many icy worlds beyond Neptune. Most thought the solar system was composed of gas and rocky planets, with Neptune as an icy giant at the edge. Initially, Pluto was considered a single planet, despite its irregularly inclined orbit. The Kuiper belt was not recognized until 1992, 60 years after Pluto's discovery. Since then, it has been understood that Pluto is not an isolated object but part of a larger group of objects in the outer solar system. Many Kuiper belt objects, KBOs, have been found that confirm the existence of this region. Pluto holds a special place in the history of astronomy because it was considered the ninth planet for many years. However, as more KBOs were discovered, especially those larger than Pluto, the International Astronomical Union decided to reclassify it. The rules determining what constitutes a planet changed in 2006, which led to Pluto being reclassified as a dwarf planet. Despite this change, Pluto will always be remembered as one of the most important discoveries in our solar system. Without its discovery, we would not have investigated the Kuiper belt as deeply as we do today. The Kuiper belt is considered an extension of our solar system because it is in the same region of space and is influenced by the Sun's gravity. The 8 major planets, including Neptune, make up the solar system, while the Kuiper belt extends to the edge of the solar system. This outer region of the solar system is distinct from the interior and is composed of icy objects such as comets, asteroids, and dwarf planets. NASA states that the material in the Kuiper belt is believed to be remnants of the early solar system from approximately 4.6 billion years ago. This allows us to observe conditions and materials from that time as if we were watching history unfold before our eyes. Today, Pluto and its moons are in this belt, along with other dwarf planets such as Haumea, Makemake, and Eris. The Kuiper belt also contains a large variety of small icy objects, making it a unique part of the solar system that we rarely see. This belt is much larger than the main asteroid belt, which contains mainly asteroids and other materials and rocks located between Mars and Jupiter. Although the asteroid belt is relatively thin and contains many small to medium-sized bodies, the Kuiper belt is more extensive and possesses 20 to 100 times more mass than the asteroid belt, both in the number of objects and in total weight. It is surprising that it has taken so long to discover this region, but the fact that it was not found immediately does not diminish its importance in the solar system. The Kuiper belt hosts a variety of celestial bodies, including small dwarf planets such as Pluto, Haumea, Makemake, and Eris. Pluto was discovered by Clyde Tombaugh in 1930 and was considered the ninth planet until 2006, when the International Astronomical Union changed the standards for planets, reclassifying it as a dwarf planet. Despite this change, Pluto, with a diameter of 2,377 kilometers, orbits the Sun along with other dwarf planets in the Kuiper belt. Researchers and experts have greatly expanded their knowledge of this distant region through their studies of Pluto, but this marked only the beginning. In 2004, a group led by Mike Brown discovered Eris, whose unique elongated shape can be attributed to its rapid rotation, adding variety to the Kuiper belt. This dwarf planet, which is approximately 1,960 kilometers wide, has revealed numerous interesting details about objects in this region. Makemake, another discovery by Mike Brown's team in 2005, has a diameter of about 1,430 kilometers. Although Makemake has no significant atmosphere, its bright surface, composed of methane, ethane, and tholins, makes it one of the brightest objects in the Kuiper belt. Haumea, also discovered in 2005, is slightly smaller than Pluto but denser, with a diameter of about 2,326 kilometers. Haumea has been crucial to the re-evaluation of the definition of a planet, helping us to better understand the diversity of objects in the Kuiper belt and how they interact with each other. These dwarf planets provide valuable information about the composition of the Kuiper belt, how it has evolved over time, and its role in the history of the solar system. Without them, our understanding of this region would be much more limited. In addition, the Kuiper belt holds an abundance of objects, possibly the progenitors of comets, due to their shorter orbits compared to the Oort cloud, which is believed to be even more distant and spherical, extending from approximately 2,000 astronomical units to possibly 200,000 astronomical units from the Sun. Both regions are composed primarily of ice and are thought to be potential sources of comets. The Oort cloud and the Kuiper belt together provide a comprehensive picture of the outermost regions of our solar system. These regions help us understand the processes that led to the formation of the solar system and the evolutionary pathways of its constituent objects. The material in the Kuiper belt is thought to be composed of remnants from the early solar system, which have remained largely unchanged for billions of years. This provides a unique opportunity to study the building blocks of planets and the processes that shaped the early solar system. Observing these ancient objects allows scientists to reconstruct the conditions that existed during the solar system's formation. In conclusion, the Kuiper belt is a crucial area of study for astronomers seeking to understand the solar system's origins and evolution. The discoveries of Pluto, Haumea, Makemake, Eris, and numerous other KBOs have provided invaluable insights into this distant region. The Kuiper belt's icy bodies, dwarf planets, and potential comet progenitors offer a rich source of information about the early solar system. As technology and observational capabilities continue to improve, the Kuiper belt will undoubtedly reveal even more secrets about the history and dynamics of our solar system. Let me know what you think in the comments box. If you liked the video, remember to like and subscribe, and I'll see you in the next video.